So today we will be talking about friction بشكل عام. The last two sessions we talked about forces and moments. Today we will continue off the topic with friction. Basically, what is friction? Friction معناته احتكاك. معناته if we have something, then let's take a simple example as if we have a box on a flat surface. then let's say we have a box, okay? And this box is being pulled with a specific force in this direction, all right? So if this box is being pulled, then there's a force F, all right? If we have no friction, then the sum of all the forces is going to be to the right in that direction, and F is equal to MA. Very simple. Then like we saw before. ولكن in the case of having friction. Friction, what is friction? مثل ما قلت هو بيكون احتكاك بين any surface, any flat surface. In this case, the surface underneath this, the red part over here. زين بيكون في احتكاك that will cause a friction force to be in the other direction. Usually I call it FR. زين you can call it whatever you want, but usually we will have a friction force that is opposite to where the motion is. This friction force is equal to mu times N. The friction force is mu times N. What is mu and what is N? N, we already know what N is. Mu, we will talk about now in this session. N is the normal force اللي هو الرياكشن فورس يكون بين surface, flat surface, and it's always شنو صار بسم الله دقيقة. Okay, 1 second. There we go. So again, N is the reaction force between the flat surface and هني, okay, with the flat surface, and then we also have the weight, which is usually W mg, and then that is from the center of this usually going downwards, اللي هو W, which is equal to mass times gravity. The friction force will always depend on the normal force, اللي هو force that is flat with the surface. But this is our normal force N. Normal force. Well, mu is something we call the coefficient of friction. Okay? This is how we can always determine the friction. The coefficient of friction is unitless, إنزين ما يعني does not have any units. The friction force will also be in newtons. And the whole point of mu is usually a standard number depending on the type of surface. يعني لو كان عندكم خشب أو حديد أو شارع اللي هو it usually in reality it has a very specific number between 0 and 1. يعني mu is always going to be a number between 0 and 1. تمام? And it is just a characteristic of any material where the box or item is flowing on top of. And this is the basics of friction. An extra thing اللي ما بيكون عندكم إياه في الامتحان بس an extra thing, mu عندنا two types of mu. عندنا mu static و mu kinetic. Okay, احنا we are only dealing with mu static in our cases. We're not dealing with mu kinetic. But mu static معناته إن there is no motion, so it is in static equilibrium or just in static. And this is if it is in kinetic, or in other words, motion. But we're not going to worry about this for now. We're just going to look at the mu static when dealing with our equations. A few extra notes about friction. Then, friction is always going to be in the direction of the surface opposite to the motion. يعني if there is a force going upwards, the friction will be countering that force. يعني بيكون opposite to that force in direction. The friction force is going to always be perpendicular to the normal force. لأن the normal force is always perpendicular to the surface it is on. فدائما بيكون في right angle between the normal and friction force. They're always going to be acting like 90 degrees apart from each other. And this always depends, this is basically what we call the roughness of the surface depends on coefficient of friction. So if we have the same case, then let's say we have the same exact case, but we are considering, and then هالcase, then بس we are considering that we have the surface over here the surface over here is a smooth surface. That is what we are going to call this. If we call this a smooth surface, معناته there is no friction force. يعني FR is equal to 0. This is what a smooth surface means. طبعا we're not dealing with smooth surfaces anymore, but in the case if someone asks if it's a smooth surface, or in a question they say assume a smooth surface, معناته this is your only forces that you have: the weight, the normal force, and the force acting upon the object. تمام? Again, a quick recap: friction is dependent on the coefficient of friction, which is a number between 0 and 1. And that depends on the material of the surface type. A normal force is always going to be perpendicular to the friction, all right? And it is also going to be mu times the normal force to find the value of the friction force. And that's all you need to know before we need to start solving the problems. خلينا نبدأ بأول سؤال. First question says, a 150 kilogram box has a is resting on an inclined 15 degree plane. ففي البداية, let us draw our free body diagram from the very beginning. We know that we have a 15 degree plane over here. And then we have a 15 degree plane over here. And we know that there is a box that is resting on top of this plane. Okay. So we have a box like this resting on top of this. تمام? This box has a weight of 150 kgs. M is equal to 150 kilograms. معناته, from the very beginning, we know that we can find W is equal to mg. W is going to be equal to mass, which is 150, times gravity. Gravity, I always assume it to be 9.81 meters per second squared. So 9.81. The weight, we can already find out, if I just grab my calculator, 150 times 9.81 يساوي 1471.5 newtons. This is the first force that we can determine. So we know that the gravity is acting at the center of the object, and it's always acting straight downwards. لأن يكون صوب الجاذبية. So this is our W force that we have already found. On a 15 degree inclined plane, this 15 degrees, we already have drawn it. هني. So it is at an inclined plane. It's not on a flat surface exactly. With a coefficient of friction, which is our mu value, is equal to 0.35 unitless, 0.35. So this is our mu value. Now, what force is acting along the plane that is required to start the box to move up? يعني نبغى نحصل احنا force that will basically pull this upwards or push this upwards, depending on how you look at it. You can put it here or down, it's the same thing. So we need to find this force F. Okay, I will call it F. And we know that we have a friction force that is going to be acting in the opposite direction. Over here we have this friction force FR. ليش؟ لأن الحين we want to push this force upwards, all right? So that it can eliminate this friction force and move upwards. This is the whole idea. And we can draw our normal force from the surface over here to the top, like this. Okay? This is our normal force. تمام? Now, هني we are just assuming the direction of the forces, and then we are only assuming. The only thing we know exactly is the normal force. أكيد بيكون perpendicular in that direction, and we know that the weight is going to be straight down. So we are confident of these two forces. Now, we need to find two things. We need to find our sigma Fx and our sigma Fy. And they are both going to be equal to 0. Why? أول شيء, what does it mean? Sigma Fx means the total number of forces in the x direction. So by the x direction, this is how I am defining my x and y plane. This is my y, and this is my x, okay? And I will assume that this is my positive x direction, and this is my positive y direction. تمام؟ y is going along the n. This is what you should usually do. Your y positive will be going in the direction of the normal force, and your x positive will be going to the right of your y perpendicular at 90 degrees. Now, we found our mu. How can we find our friction force? We need to first find our normal force. So how can we do that? First, we need to break into components the weight. ليش؟ لأن الحين إحنا عندنا weight not on any axis specifically هني. So what we're going to want to do is we want to break it into a component in this direction and into a component in that direction. So if I want to just increase the size هني عشان بس تشوفون, for the weight is straight down. احنا نبغى يكون عندنا weight force along the plane. هذا هو البلين يعني. Alright. وبعدين بيكون عندنا another force that will be perpendicular to it. Okay. So we're going to have a weight here and a weight here. And we know that this angle is 15 degrees. It's an inclined plane. I'm just drawing the same thing. I'm just drawing it a bit lower عشان يبين شكله كيف. How can we break this down into these two? Let's call these WX because this is in the X direction and WY because this is in the Y direction. We need to figure out the angle between W and one of these. إذا الحين we wanted to just complete this triangle, we will notice that we have a right triangle. All right. If this is 15 degrees, this is 90. A triangle has 180 degrees. Okay. So 180 degrees minus 15 minus 90. So minus 15 minus 90, we will get this angle, let's call it theta. Theta is going to be equal to this, which is equal to 75 degrees. You can either do it this way and find out that this angle is 75 degrees, or if you are good with your math skills and you know your trigonometry very well, you will instantly know that if this is 15 degrees, because this line, this is a perpendicular that is forming over here, this is also going to be 15 degrees. لأن this is perpendicular. So whichever way, both ways are correct. It's about how comfortable you are with your trigonometry to figure out how the angle is. Okay. So me personally, I like to use the 15 degrees over here. So that's what I will be looking at right now. I'm not going to look at the 75 at all. Okay. الحين حصلنا الانgle between weight and one of the components. Now we can apply our SOHCAHTOA. Okay, the way I apply it using the shortcut is this. So if you remember SOHCAHTOA, then we're going to be looking at either the SO or the KA. We are going to look at WY first. Okay, let's see WY. So WY is going to be equal to W times, it's either cosine or sine. How do we know? We look at whether this is adjacent to y, the angle, or is it opposite? It's adjacent to it. 15 is adjacent to the WY that we need to find. So it's going to be cosine 15 degrees. Why? لأن A is the adjacent part is in the cosine part of SOHCAHTOA. The sine part, the WX part, I mean, this is going to be W again. Now it is going to be sine. Why? Because if you notice here, the opposite, the angle here is going to be opposite to WX. So it is going to be sine 15 degrees. Times W times W. This is just the shortcut method I like to use. You can use the forced triangles, which is explained very clearly in the first video I have done, to determine it, but it will take a lot of time if you want to do it that way. So I would recommend getting used to this shortcut. Okay. Once we are done with all of this, we can just calculate this now. W is equal to, we found it earlier, 1471.5. So 1471.5 cosine 15 degrees. And this is 1471.5 sine 15 degrees. This is going to be equal to 1471.5 cosine 15 is equal to 1421.36 newtons. And the second one is going to be sine 15, which is 380.85 newtons. Okay? So we found our Wx and Wy, which are the components we need to solve this shape now using sigma fx and sigma fy. So if I just copy paste this again one more time down here. After we did the analysis, now we don't need to look at the W. We already have broken it into its parts. We know that we have W here, Wx in this direction. All right. Wx in this direction. And we have Wy in this direction. And we have found the values of it. Then, now we can apply our sigma fx and sigma fy is equal to 0. Let's start with sigma fy. On the y-axis, which is this direction over here, as you can see, this is our positive y, we have plus n minus wy. This is equal to sigma fy. So sigma fy is equal to plus n minus wy. ليش? These are the forces that are acting in the y direction. We have n in the positive direction of y, and we have wy in the negative direction of y. So this will all be equal to 0. Okay? We already have the value for wy. We just need to find our n value now. So n is going to be equal to wy. معناته n is equal to, what was our wy that we found earlier? 1421.36. 1421.36 newtons. Now we have found our n value, which is equal to our wy. This will almost always be the case, by the way, where wy is going to be equal to the normal force, almost, as long as there are no other forces acting in this direction. Now we can find our friction force. Our friction force is equal to mu times n, اللي هو equal to mu. We have been given in the question that mu is equal to 0.35. 0.35. تمام? And n, we just found it to be equal to 1421.36. So the friction force is going to be equal to, just put that in the calculator, 1421.36 times 0.35. It is equal to 497.48 newtons. We found our friction force. Now we're going to need to find our last force, which is the question, what the question is asking. We need to find the force F here that is required to start the box moving up the plane. Okay? Now we can use our sigma Fx equal 0. If I just copy paste this down one more time. And then, how are we going to use this? So we are going to look at the x direction now. So basically, we're looking at the ones that are going up and down the incline. And we'll go step by step. So we know that F is our positive. Let's start from the right. We know F is going to be positive. So sigma Fx is equal to plus F, positive F, because it's in the positive x direction, minus Wx, because it's in the opposite direction, and minus Fr, because it is in the opposite of the positive direction. بعد أقول the positive direction, you guys can choose it whichever way you want. تقدرون تعكسونه بالكامل. You can make down and left to be your positive. No issue there. Just make sure you are following the same sign notation so you don't get confused. And this, all of it will be equal to 0. So F is going to be equal to, we will just take the W and the FR to the other side. فبيكون WX equal to Wx plus FR. Okay, and we have the values for Wx and Fr, and we can just plug them in to find our force F value. Ali, you can go ahead and ask, it's fine. I can repeat something if you want me to repeat it. For Wx plus Fr, and then a Wx that we calculated early on here, which is 380.85. 380.85 newtons, plus FR, which we found earlier to be 497.48 48 newtons. And now we can find our final force, which is 380.85 plus 497.48, which is equal to 878.33. Okay, and we found our final answer, newtons. 478.33. Now, yes, I will explain the plus and minus. If you notice first, before that, here we got a positive answer for our question. معناته, our assumption was correct from the very beginning. The force has to be upwards, not downwards, which makes sense. So, how did I choose my plus and minus هنا? From the very beginning, at the beginning of the very question, زين, and I always choose this as my positive directions. You can always choose anything you want, but me personally, I prefer choosing these directions to be my positive y and positive x. زين. So because I chose these to be my positive directions, الأكسس هذا, I will follow these. Any force that is going in the same direction as the x will be positive, يعني in that direction, upright, and if it's going bottom left, it's negative. زين. So إذا رحنا هني to the final one, this is our x, okay? I will take this arrow and compare it to the f. Is it in the same direction? Yes, it is, so it is positive. I will compare it to wx. Is it in the same? لا, it's opposite, so I will put negative. I will take it here to the friction. Is it the same direction? No, it is opposite, so I will put negative. That is what I basically did. Same thing with the y. When I did sigma fy, then I was looking at this. I was taking this arrow and checking with the normal force. Is it the same direction? Yes, so n is going to be positive. With wy is the opposite, so it's going to be negative. And that is the whole concept of how to solve it when you have an inclined plane. Let's move on to another inclined plane question. زين. What force parallel to the slipway is required to lift a 1.5 ton boat up an incline of 20 degrees? زين. فأول شيء, step by step. So we know we're looking for a force. What force parallel to the slipway? فنعرف إنه we're going to have a force to deal with. Let's name this force F. This is the force that we are going to need to find. Because it's asking what force is required to do what? To lift a 1.5 ton. We are given the weight of the boat, 1.5 tons. So M is equal to 1.5 ton. First thing I will do is convert this into kilograms before solving anything. We have to be in SI units. Just so you know, 1 ton is equal to 1,000 kilograms. All right. So M is going to be equal to 1,500 kilograms. You just multiply by 10 to the power of 3 or multiply by 1,000 to get it into kilograms. Then, so our mass is 1,500. Okay. Now, what else is given? We are given an incline of 20 degrees. So we know we have an angle. فالحين we can draw part of our free body diagram, which is like this. We know we're going to have an angle over here of 20 degrees. And we are also given the coefficient of friction mu is equal to 0.25. If you notice, it is almost exactly the same as the previous question. We're going to be applying the same concepts as well. The only trick here is we had to convert from ton to kilogram. And that's it. So let's assume the boat is like this in shape. And then, same exact idea again. We have weight that is acting downwards, W. We can find the W instantly. W is equal to mg. So it's equal to 1,500 times 9.81. So W is going to be equal to 1,500 times 9.81. It's going to be 14715. So 14,715 newtons. Okay, so we found our weight. We know that the force parallel to the slipway is required to lift. Because it says lift, we know it is going to be going in an upward direction somehow. And it has to be parallel to the slipway. So the force is going to be acting like this, parallel to this line over here. And then we know that much. This is where our force direction is. Remember, friction is always going to be opposite to the direction of where the force is being applied. This is our friction force. And then we have our normal force, which is just simply in the upward direction from the surface of where we have. And then we solve the exact same way. So the first thing I will do is I will define my directions again. So this is our positive x and positive y. This is plus x, and this is plus y. Okay? So these are our directions for the plus x and plus y. So we'll follow that standard. Before I do anything, I need to break down my W into its two components, which is like this. We're going to have a force here W and the force here W, the components of it. So this is we will call WY because it's in the Y direction, and this we will call WX. Again, the analysis will be the exact same way. If I just copy paste this again down here, we know that if I erase everything around this, if we just look at the W forces, then we know that we have a 20 degree, we have a 20 degree line, then. So this is 20 degrees, okay? So this will be also 20 degrees, okay? Because this is going to cause a right triangle over here. So, and this is a right angle over here. So this has to be 20 degrees, tamam? So now that we know that this is 20 degrees, we can find our WX and WY values. WX is equal to W, the opposite, so we're going to use sine of 20 degrees. And WY is equal to W cosine, because it is adjacent 20 degrees, just like I did before. Let's just put in the W value, which is 14,715 times sine 20 degrees, which is equal to, and 14,715 sine, cosine, sorry, of 20 degrees. Let me just move this a bit to the side. And then, so this is going to be equal to, I just plugged them into my calculator, 14715 sine 14715 sine 20 is going to be 5,032.83 newtons, and the other one is going to be cosine 20, so it's going to be 13,827.58 newtons. Okay, so I found my values, I found my cosine, and I found my sine. Now I know my WX and my WY, so I'm going to take this again, same formula. Normal force is always going upwards. Yes, normal force, شوف, a normal force is always going to be upwards from the direction of the surface. يعني إذا عندنا السيرفس كذي دائما a normal force بيكون perpendicular to the surface and going upwards in the direction of the box or of whatever is sitting on that face. Okay? So now we don't need the W force because we found the components. We can just look at the components we have. And we can start solving for sigma Fy, which is equal to 0. Then there is no motion in the y direction. Okay, it is in equilibrium. Sigma Fy is equal to 0. So sigma Fy is also equal to n plus positive n because it's in the direction of y, minus Wy because it's in the opposite direction of y, and this is going to be equal to 0. Therefore, n is going to be equal to Wy, which is simply equal to Wy was 13827.58 newtons. Okay, now that we found our normal force, we can find our friction force, Fr. It's going to be equal to normal mu times the normal force. So mu times the normal force. So it's equal to, our mu is given to be 0.25, and our normal force we just found is 13,827.58. Okay, multiply this and you'll find your friction force. Fr is going to be equal to times 0.25, 3,456.89 newtons. Tamam? As you can see, it's very similar to the previous example. Now that we found our friction force, we can do our sigma Fx in the x direction to find our actual force. Let me just, excuse me, let me just copy paste this down here. Okay. فعندنا الحين ال F, sigma Fx is going to be equal to, let's look at what we have in the x direction. We have a positive F, we have a negative Wx, and we have a negative Fr. And this is all going to be equal to 0. All right? So if I just reorder this equation, F is going to be equal to Wx plus Fr. So F is going to be equal to Wx we found earlier was 5032.83, 5032.83 plus friction force we found right now 3456.89 newtons and newtons. So the final force that is required to lift up the boat is going to be equal to 5032.83 plus 3456.89. It's going to be 8489.72 newtons. Another way you can write this down is as you can write it in kilonewtons as 8.49 kilonewtons. Okay. Sometimes you might see it, you might write it in this way, sometimes in this way. All I did was divide by 1000 so I can change the unit. Okay. Both answers are correct. You don't need to worry too much about that. But as you can see, the solving is almost exactly the same as any other case. Let's solve one more inclined question. Let me see a fun one to solve. Okay, I think question 3 is a bit different. A load of 20 grams slip plane slightly. Okay. Let's solve this one. Let's see what is the man's largest man to be dragged. This is easy. Excellent. Okay, this is a more important question in my opinion, which is question 3. Aishan, I can start with the ladder problems because those are going to be the ones that will take a while to solve. So, هني, we have a load of 20 kilograms. So we have a load of 20 kilograms. Instantly, we can just write M is equal to 20 kilograms. معناته W is going to be 20 kilograms times 9.81 because it's just mg, okay? So W is equal to 20 times 9.81, which is 196.2 newtons. We got the weight and we are done with that. Resting on an inclined plane and begins to slip when the plane is tilted to an angle of 25 degrees to the horizontal. 25 degrees معناته we know that the plane is going to look something like this. And there's 25 degrees. Okay? And it is about to slip. What does slip mean? Slip mean يعني تخيلوا الحين انتم يوم تحطون شيء على يدكم, okay? If you put something in your hand, زين, you start angling your hand in the opposite direction, eventually it will fall, it will slip from your hand أو بيطيح. فلو تخلون ايدكم horizontal and then you start angling it towards the ground, you will reach a specific angle where the item will slip. ليش؟ لأنه عادة في friction. يعني أنا الحين ميود الكالكوليتر في إيدي. الكالكوليتر I'm doing a lot of angles but it's not falling لأن there's a lot of high friction, a high coefficient of friction that is holding it between my hand and the calculator. But if I reach a specific angle, my calculator will fall because I have exceeded a specific angle and it slipped from my hand. That's what it means. Sorry if that was too loud. I didn't actually mean for it to fall. Now, what force parallel to the plane will be necessary to keep the load from slipping down the plane? Okay. فمعناته عندنا بعد exactly the exact same question. Nothing has changed. زين. But here, if you notice, they did not give us any mu value. زين. We do not have any mu value. تمام? So, we're going to start solving now. We need to find the force F that will keep from slipping down the plane. And just barely keep it slipping from down the plane. We will draw our forces again. طبعا the friction force will be downwards, opposite to where the force is going to be applied. So this is our friction force. هني بيكون عندنا الفورس, the main force pulling it up, F, and then a normal force that is perpendicular to the surface. And then we have our weight, which we have already found, which is downwards like this, and it has its components. But now this time we do not have mu. ولكن هني it says something very important. What force parallel to the plane will be necessary to keep the load from slipping? Keep the load from slipping. معناته شو؟ معناته we don't want a load to slip. We don't want there to be slippage between الفريكشن هني يعني هذا it's not overcoming friction and falling بما معناه. Okay, that's what this means. So we need this force to be keeping this thing stationary at all times. All right. I'm trying to think of a way to solve this without mu. We'll get there. زين. خلينا we start step by step. So we found our weight. Let's break the weight into its components. Again, always the same step. Okay, Wx and Wy. Why am I calling it Wx, Wy? Because my positive y and positive x are in these directions. So plus x plus y. Okay. Now, we have the sigma of x equation, and the sigma. First, let's find Wx and Wy. Wx is going to be, because this is similar to the previous examples, I'm just going to write it instantly, just as we did here earlier. Wx was W sine and Wy is W cosine. So Wx is W sine and Wy is equal to W cosine. The angle here is 25 degrees, 25 degrees. So this is going to be equal to W is 196.2 newtons. And this is going to be equal to 196.2 newtons as well. But this is sine, 25 degrees. This is cosine, 25 degrees. So we're going to find the value for each. 196.2 times sine 25 is 82.92 newtons, and cosine 25 is going to be 177.82 newtons. Okay, so this is the components of here, so we can just copy paste this now and remove the W in the middle because we have already broken it down into its components. So we can remove this. We don't need this anymore. الحين عندنا sigma of x is equal to 0. So sigma of x is also equal to وين sigma شو كتبها الأحمر إيه؟ لا أسود. Sigma of x is also equal to f plus f. ليش؟ لأن it's in the positive x direction. So I'm just going to write the equations down instantly now. Minus wx minus fr. We still didn't find fr, but we can break it into its components and we will look at it in a little bit. زين. And the same thing again with fy. Oh, this is going to be equal to 0, obviously. Same thing we will do with fy. Sigma fy is equal to 0. Okay. Sigma fy is going to be equal to 0. Just 1 second. Sorry, excuse me, 1 second. Sorry about that. And then, so Fy is going to be equal to sigma Fy is equal to 0. Bad, same thing. Sigma Fy is going to be equal to N minus positive N minus W Y, and it's also going to be equal to 0. Okay. إذا حلينا هذا الحين نقدر نحل السيجما Fy. So we know that N is equal to Wy, which is equal to Wy طلعناه 177.82 newtons. All right. Now we just need to find our mu. Keep in mind here in the question, what does it say? What force parallel will be necessary to keep the load from slipping? لأن on an inclined plane it begins to slip. بما معناه الحين it's at a point where it is about to slip. The way you will find the coefficient of friction here is by just simply using this equation. Mu is going to be equal to the tangent of theta. This is just القانون, where theta is the angle of the incline. And then where theta is angle of incline. ليش؟ لأن في السؤال in the question itself they are mentioning that this is the angle at which it will begin to slip. Okay, so this is the rule you're going to use. Mu is equal to tan theta, فمعناته mu is equal to tan of 25 degrees. So mu is simply going to be equal to tan of 25 is equal to 0.47 and it's unitless. Okay, so this is how you will find your mu in the case when they say the plane begins to slip when the plane is tilted. فمعناته at this angle it starts slipping. معناته at this angle we're going to find the mu depending on that tangent of that angle. تمام? Moving on, we found our mu, we found our n. We can find our friction force now very easily. It is equal to mu times n. So it's simply equal to mu is 0.47 times n, which is 177.82. Okay, so our friction force is going to be equal to 0.47 times 177.82, 83.58 newtons. Tamam? Now we have our friction force and we have our Wx. Now we can apply this equation and just simply solve directly for F. So we know that F minus Wx minus Fr equals 0, just like before. F is going to be equal to Wx plus Fr. So it's equal to Wx was 82.92 plus the Fr is 83.58. So F is going to be 82.92 plus 83.58. It is going to be equal to 166.5 newtons. And that is basically how you would solve such a question. So the trick here is, you are going to make sure that you are. Oh, I just realized something I did wrong, but I'll explain it in a bit. And then, but the trick here is you need to understand that the angle of the incline mu, and then, is equal to the angle of you can find mu when you find the angle of the incline at the point at which any item is slipping. And then that way you can just find it by using this equation, which is tan theta is going to be equal to mu. Now keep in mind I did not solve this right. ليش؟ لأن مكتوب what force parallel to the plane will be necessary to keep the load from slipping down the plane if the angle of the slope is increased to 35 degrees, which I did not read. فالحين the answer that I found is for when angle is equal to 25 degrees. Okay, so this is at angle is equal to 25 degrees. So that was a mistake from my side. I did not read the question fully. The actual angle I'm supposed to put is 35 degrees. زين. So this, everything else is exactly the same solving, but this should be 35 degrees. All right. However, this is only going to affect your WX and WY. The tan theta is still tan 25 لأن slip is not occurring at 35 degrees. The slip is occurring at the 25 degrees. So the only values that will change here are these values. Instead of sine 25 cosine 25, it will become sine 35 and cosine 35, which will change our entire solution. So if I just rewrite this down here again, all I'm going to do is remove the 2's here, the 25's, and I'm going to put 35. 35, and then I'm just going to calculate for the new one, 96.2 sine 35. So this is equal to 112.54 newtons, and this is going to be equal to cosine 35, so 160.72 newtons. And now when we do our sigma of x and sigma of y, our n is going to change, obviously, because it's equal to wy. So n is equal to wy, which is equal to wy is 160.72 newtons. This is our n. So our Fr is going to also change. It's equal to mu times n, which is equal to, mu is the same. Mu does not change. Then it doesn't get affected by this angle. Mu comes from the angle of the slip. So it's 0.47 times this new force, or this normal force, which is 160.72. زين. الحين FR is going to be equal to a new number, which is times 0.47, 75.54 newtons. Okay, 75.54 newtons. Notice one thing though. زين. هني normal force was 177.82. Here the normal force is less. معناته your friction force is also less. ليش؟ لأن there is more weight being applied in the x direction. لأن you're increasing الحين الانgle, so there is already weight that is causing you to have an extra force. So the amount of friction is going to be reduced لأن in the same direction you have the weight of the object that's pulling it down. يعني this is just a logical thing. يعني if you look at WX عندنا 112.54. قبل WX كم كان؟ It was only 82.92. لأن كان الانجل أقل. لأن the more flat you go, the less the gravity will pull it down. لأن بيكون عندكم a higher normal force. There's going to be more reaction to hold it back up. This is the whole idea. Now, let's continue solving this finally. So we have this equation. We're just going to have to apply it again. So now our F is going to be equal to Wx plus Fr, which is Wx, now we found it to be 112.54 plus 75.54. F is going to be finally at 112.54 plus 75.54, which is 188.08 newtons. Again, nothing wrong with what I did from solving, from the point of view of solving. My mistake was in I had to I did not consider the directions properly. I did not consider not the direction, the angle properly. زين. And because I didn't consider the angle properly, this is how I got slip. زين. Is this clear? Okay. I just noticed one more thing. Anna, I forgot that we are dealing with slip here. So, what does this mean? Anna, we are not considering friction force now in this way. We have to consider it in the opposite way. لأن أنا شو كنت قاعد أقول? The motion is going into this direction. It is falling. And this was a mistake on my side as well. We were saying that this is falling, okay? Because this is falling, the friction is going to be in the opposite direction. So it's going to be going upwards. ليش؟ لأن الحين احنا we need a force to hold it still, because the friction is what's the only thing holding it back. We are not moving this object upwards. لا. This object is falling downwards. So the friction is the only thing holding it back. This is just an additional force to support the friction holding it up. That was a mistake on my part. I did not notice that early on. بس احنا we have the object falling from our hands, like earlier I was saying in the calculator. The only thing keeping it up was friction. And then when I'm angling my hand down, what was pulling it down is the weight, the W. And what's keeping it up was the friction force. So in this case, because of slip, we are going to have the friction in the opposite direction. So this is going to be plus Fr, not minus Fr, in all of my solving. I apologize for the mistake that I did. So again, this is going to be plus Fr, and then so when we are coming to the solving, it is going to be plus Fr هني. So this is going to become minus Fr when we take it to the other side. If you notice here, we get a negative force because we are finding the angle at 25. So the force here, this is at angle 25. We're going to find the negative value, which is 82.92 minus 83.58. لأن this isn't what we're trying. It's minus 0.66, almost no force. What does this mean? لأن to keep it from slipping, you need a force of nothing. It's almost about to slip. It hasn't slipped yet. So technically, you almost need no force to keep it at place. If the angle increases, that's the time where it will slip. فلازم الفورس يكون close to zero هني. But that's not even the part of the question, so we're not going to look at this part. This is where we are actually solving the question. The force here is going to be in the opposite direction. And then لأنه we are trying to stop the slipping, so the friction is happening in the opposite direction. هني الفriction force بيكون positive لأن now the friction force is within the same direction. So this is going to be minus, not plus. All right. And our final force is going to be equal to 112.54 minus 75.54. So it's almost 37 newtons. Okay. Again, apologies for the mistake. I should have read the question carefully. This is what happens when you rush through a question. And if بالي حاط and I want to finish quickly so I can do ladder, and I forgot to apply my basic concepts. But you can learn from my mistakes, and you can make sure that you're applying everything in the correct way. مثل ما شفتوا, again, the reason the friction force is upwards is because this object is slipping. It is falling down. لأن it is falling down, all right, معناته this friction force is acting in the opposite direction. Remember that friction is always acting in the opposite direction of motion. فإذا الحركة قاعدة تروح على تحت, الفريكشن لازم يكون على فوق. This force is an additional force that is there to keep the load from slipping. يعني احنا قاعدين نحط هالفورس so that the load does not fall down. هاي كأنه لو انت قاعد تنزل الكالكوليتر شوية وبيطيح, تحط صبعك من ايد الثانية عليه عشان ما يطيح. بس that is what that force is. Okay? And that's pretty much it for this question. Let's take a 5 minutes break عشان أجمع أفكاري شوي حق اللادر. And we will continue again at 11, 10. Okay? Inshallah, we'll continue at 11:10. Let's take just a 5-minute break. Back at 11:10 p.m. Anyone has any questions about this? You can ask me right after the break. So think about the question and let me know if you have anything that needs clarification before we go into ladder problems. All right. So as you can see, I made the mistake. When did I make the mistake? When I started the question at the very beginning in the drawing itself. So it is very important when you are drawing, you take your time reading the question and making sure the drawing is correct. لأن that's when most of the mistakes will happen. إذا الدروينج مالكم غلط الحل مالكم كله بيكون غلط نفس ما صار فيني قبل شوي. So now I'm going to take my time while doing these ladder questions so that we do not make any mistakes in the original drawing that we begin with. All right. So let us start. A uniform ladder. When they say a uniform ladder, meaning يعني the weight of it is normal. إنزين. يعني ما بيكون أثقل فوق أو أثقل تحت. A uniform ladder rests against a smooth wall with its lower end on a rough ground. Okay. يعني. What does this mean? So first, let's draw it. We have two walls. Okay. And we have the ladder resting like this on it. Okay. Here, we know that first thing they say, it rests against a smooth wall. Yani the wall is going to be smooth. What does this mean? It means here we have no friction. No friction. معناته mu is equal to 0. يعني FR is equal to 0. There's no friction force on this side of the wall because it is a smooth wall. With its lower end on a rough ground. Rough ground, شو معناته؟ معناته we have friction. So here we're going to have a rough ground. There's going to be a mu value here. In this part, there's going to be a mu value. And mu is given to be equal to 0.45. All right. Find the inclination of the ladder to the vertical floor. The inclination of the ladder to the vertical, meaning this angle over here to the vertical. And then, so the inclination of the ladder to the vertical, we're going to look at the angle with the vertical wall, which is here. Let's call it theta. When it's on the point of sliding. Again, we are mentioning sliding here. Sliding معناته شنو؟ معناته it is about to slide off. يعني it's almost about to go into that direction, into the right direction. صح? Because if this is going to slide, what are the directions it's going to slide in? It is going to slide in this direction, in the bottom, towards the down part from here, and in this direction it will slide there. What does this mean? Let me actually put these in black. So if it will slide like this from the top to the bottom, and it will slide from the left to the right like that. The wall is smooth, so we don't have any friction force here. However, we have a normal force pointing, all right, towards the ladder. All right. This is the same as saying we have a friction force or a normal force. هني. زين. This is our normal force. Okay. But the reason usually it's drawn on the other side is it just makes it a little bit easier to see. That's it. عشان it does not get too confusing. So we can just draw it on that side. Let me just erase this. And we could just draw it on this side. It is the same thing. This is our normal. لأن the normal force is always in the opposite direction of the wall and perpendicular to the wall. This is the normal. Let's call this normal 1, N1. Okay. And this is going to be also sliding on the right side. However, here we are going to have a friction force in the opposite direction. Okay, because we have a mu of 0.45. So there's going to be, it's not a smooth surface, so there has to be a friction force that is holding up the ladder. Let's call it FR. And we're going to have a normal force again upwards. So we could just do it this way. Okay, we have a normal force here. Let's call this N2. Tamam? Obviously, this ladder, it did not mention anything about it being weightless. So since it's a uniform ladder, it's going to have a weight that is also going downwards here. This weight is W. All right. And let's assume that the length of the ladder is just L. L, the letter L. okay? Because we do not know what the length of this ladder is. The most important dimensions you guys will need to know is the y and the x dimensions. What does that mean? We're going to have an x dimension here, from here till here. Let's use a different color. Let's do x as blue. From here till here, this is going to be our x, okay? And then we're going to draw our y. We're going to have y from here till here. This is our y value. And then, which we also do not know. The only number they gave us, the only value they gave us is the coefficient friction of the floor. So we know that if we just write the equations that we know that sigma, or first of all, I always will start with friction force. So Fr is equal to, in this case, N2 times mu. So we know that our friction force is going to be equal to 0.45 times N2. Okay? We don't have the value of N2, but we will try to figure it out later. This is the first thing that we can find. We know that N2 is going to cause the friction force, or is going to help us calculate the friction force. Yeah, and that's it. And now we can go in and do our sigma fx and sigma fy to try to simplify a little bit the forces that we have as well. Okay? So sigma fx equals 0. معناته شنو? We're going to look at our x. So again, if I'm choosing my x plus and minus, let's choose it in this way. Plus x plus y. It doesn't matter if you choose it left or right, it's the same. I usually prefer using it this way. So sigma fx equals 0. The only force that is applied on the x is the Fr over here and the N1 from up here. Okay, so we know that N1, the sigma fx, is equal to N1. Let me change the color of N1 to blue عشان ما يكون في too much confusion. Let's change it to blue. Okay, to blue عشان we don't confuse N1 with N2. So this is N1, our blue. All right. So sigma of x is equal to N1 is positive plus N1 because it's going into x direction, minus Fr because Fr is going in the opposite direction. تمام? And this is equal to 0. So N1 is equal to Fr. This is our first relation that we have managed to find. Actually, our second one. The first relation, we found a relation between Fr and N2, which is the basic one. The second one, using the sigma of x, we found N1 is equal to Fr. So we already have a relation between N1 and N2 if we want to substitute it back into that equation later on. But we will continue solving until we find out what we need to do. Okay, so moving on. Now we will use our sigma Fy, which is equal to 0. Sigma Fy, what do we have? We have the weight and we have N2. So we have N2 in the positive positive y direction. So sigma Fy is equal to plus N2 minus W. And the W is going downwards. So, and this is equal to 0. So in other words, we know that N2 is equal to W. All right? N2 is equal to W. فالحين عندنا this equation over here. We found this equation. Let's number them. So we have equation 1, we have equation 2, and we have equation 3. But how many unknowns we have? We have one unknown N2, two unknowns Fr, third unknown is N1, and we have a fourth unknown, which is the weight. So we have 4 unknowns, but only 3 equations. To solve for unknowns, we have to have as many equations as we have unknowns. So we can use what we learned from last session, which is finding the moment about a point. So we can use the sigma moment is equal to 0. All right, sigma moment, which moments are we going to take? We can take one of 2 points. We can either take the point up here. All right, let's name this point 1. This point is point number 1. Or this point, point number 2. Okay, اللي هو الpoint at where the ladder is hitting the floor. Usually, when you want to choose a moment where you have so many forces at that moment directly. Why? Because that way you will be able to cancel out as many forces in your moment equation. لأن these force FR and N2, in this case, will have no perpendicular distance with the point number 2. So we will be able to remove them from يعني من الحسبة completely. All right? So we have sigma moment equals 0. Sigma moment about 2. All right, so this is m at 2 is equal to 0. And now we can, let me just copy paste this down here. And now we can start solving for the perpendicular distances. Then, now, to solve for the perpendicular distance, we need to know some basic trigonometry. Okay. So we are finding the moment here. The force due to these is not going to count. We don't care about the FR and N2, but we care about N1 and we care about the L, the W, the weight W. Okay. How can we do this? All right. So first things first, we know that the perpendicular distance for N1 is Y. This is already clear, very clearly written. We have the distance Y. So perpendicular distance for N1, let's write it in blue. The perpendicular distance for N1 is equal to the letter Y, or the distance Y. We know that, all right? Now we need to find the perpendicular distance from the weight to the point 2 over here. So if I draw a perpendicular line to this point, we're going to have this triangle, that is this red triangle that will form. Let's analyze this triangle so that we can move on. So if I just redraw just the triangle that we got, this is what it looks like. And this is where your trigonometry skills will be very important. For we know it's a uniform ladder, فنعرف إن الweight is acting exactly in the middle. For we know that this distance here, this distance is going to be half of x, this distance from here to here, which is equal to this distance over here. So this is going to be x over 2. Okay, that's the first thing we found. Same thing with the y. We know that this distance from here to here is going to be y over 2, or half of y. So this distance as well is going to be half of y. Okay, so this distance we found to be y over 2. Okay, and this is going to be the half of L over 2. Again, this distance, this purple one, is going to be, and because the W is acting right in the middle, so this distance is half of L. So here we know that this is half, or L over 2. Okay? Now the way to solve this is, we want to find the relation, since this is a right triangle, we want to find the relation where we are getting rid of as many variables as we can. We also know that this angle over here is angle theta that we have assumed, because this angle over here is going to be equal to this angle over here, because they are both with a vertical line and along the same line. So these are both equal to theta. الحين we can simplify this equation a bit more so that we can find out what our x and what our y is equal to. Okay? If we look at the big triangle as well from the beginning, the very big triangle اللي هو اللادر. Okay? Actually, this is the y. you'll see that it is very, very similar to the triangle that we have just drawn over here. عندنا هنا x, عندنا هنا y, and we have here the length L. زين. So, and we have the angle theta obviously over here. This is a right triangle. So we can find an equation for y and x directly from this. We know that y is equal to, if we use SOHCAHTOA, all right? So, let me write it in black actually, it's better. And then a SOHCAHTOA. Okay. L is our hypotenuse. This is our hypotenuse. Y is our adjacent, and X is our opposite. Okay. So we want both of these to be in the terms of L. So we want to have every equation to be equal to the L so that we can cancel out as many as we can. So we know that Y is equal to L. Let me do it the full way, the full method. And then, so first we'll look at the Y. The Y, we have adjacent and we have hypotenuse. What has adjacent and hypotenuse? K. So cosine theta is equal to adjacent over hypotenuse, which is equal to Y over L. Okay. So cosine theta is equal to Y over L. So if we rearrange this equation, we can see that Y is equal to L cosine theta. All right. This is the first one. We found the one for Y. Let's keep this here on the side. Let's do the exact same thing again now for X. So we need an equation of X and L. We have opposite and we have hypotenuse. What has opposite and hypotenuse? The sine. So sine of theta is equal to opposite over hypotenuse, which is opposite is X, over hypotenuse, which is L. If we rearrange this equation, we're going to get X is equal to L sine of theta. Okay. Now we have found relations between Y, X, and L so that we can substitute later on for X and for Y, and we will only have L and theta as our unknowns. Because at the end of the day, we're trying to find out what theta is. This is what we're trying to achieve in this question. And then, so now we found these relations, and we found our perpendicular distances. Okay, we found our perpendicular distances. So the perpendicular distance for W, so we found our perpendicular distance for N1 is Y. The perpendicular distance for W, I'm going to actually write them on the left side here, تحت المومنts. The perpendicular distance for W is equal to, what is the perpendicular distance? It is this distance over here, which is from here to here, which is half X over 2. It's this distance. Okay, it's X over 2. So X over 2. So now we know the perpendicular distance for W and we know the perpendicular distance for N1. Now we can finally write our moment equation completely. So let's move this all down here. Then we know these are the perpendicular distances. Let's keep them on the side. So sigma moment equal to 0. The first moment we have is, again, just a reminder, moment is simply the force times the perpendicular distance. All right. The first moment we have is the one for N1. So it's going to be the force N1 times its perpendicular distance, which is Y. The second one we have is, I'm not going to put pluses and minuses yet. لأن بعدين I will show you how to get the plus and minus. The second distance we have, the second force we have is W. All right. And its perpendicular distance is X over 2. And these are equal to 0. These are both equal to 0. Before adding and subtracting, let's look at our diagram. Let me copy paste this one more time. Let's keep it here. Okay. So how do we know whether it's plus or minus? First of all, we need to determine our direction. I usually take clockwise as my positive direction. So I will consider clockwise as positive and counterclockwise as negative. So let's look at N1. N1, the direction of it. It is going towards, the way I do it is I take it and I go towards the point that we are trying to find, which is point 2 over here. So you can see it has this direction for it. This is for N1. So N1 is going to be clockwise, so it is positive because the direction is clockwise. Now for W, I'm going to connect again. This point, I'm going to look here. It is going in that direction. So it's going into this direction. So it's going counterclockwise. So it's going to be negative. So this is going to be minus W. All right. So this is the equation now that we have over here. Okay. This is going to be equal to 0. We can simplify this a bit more. N1 times now بنبغى نعوض حق ال y. Remember earlier we found relations for y and x. Now we're going to use these relations to substitute them back into we're going to use these two relations to substitute them back into this equation. Okay, so we have y is equal to L cosine theta minus W into x, which is L sine theta divided by 2. Okay, actually let me make them in the same colors so you guys know what I'm substituting. So this is going to be L cosine theta. And then what I'm substituting here, and here I am substituting L sine theta over 2. All right? And this is all going to be equal to 0. احنا طلعنا هذيله from the relations of the x and the y from trigonometry earlier. So now we can simplify this equation even more. أول شيء بنخلي N1 L cosine theta on one side, and we will take the other thing, the W, to the other side, which is W L sine theta over 2. You notice if we divide both sides by W, if we divide here by W and we divide here by by L, we can cancel out the L's from the equation completely. So we no longer have L in the equation. This was the whole purpose of doing X and Y as a substitution and getting cosine theta as well. This is why you can also assume from the very beginning that L is equal to 1 if it gets too confusing. You can always assume L as a unit length, so you can assume it's equal to 1. But this method also works if you understand what you're doing. فبيبقى لنا N1 cosine theta is equal to W sine theta over 2. Okay, so remember, theta is the answer we're trying to get. And this theta over here it's the answer we're trying to get. And this is our fourth equation. This is our fourth equation. زين؟ فطلعنا الحين relations احنا between almost everything. So if I just go bring all my equations back now and compile them all together, we can start solving. So let's bring this equation down here. This is equation 1. Let's look at equation 2, which was this, N1 is equal to FR. Let's bring down equation 3, which was this, N2 is equal to W. And let's bring down the last equation that we have done, which is this one, equation 4. N1 cosine theta is equal to W sine theta. Okay? So the easiest way to cancel this out is first, we know that there's a relation between FR and N1. Okay? معناته we can simply get rid of FR and put N1 in its place. So from these two equations, we can say that N1 is equal to 0.45 times N2, which is in green. Okay? ليش؟ لأن N1 is equal to FR. The same thing here. We have WN2 and we have W here. So we want to get rid of W again. So what can we do? We can look at these two equations now. And we will substitute N2 instead of W. فبيكون N1 cosine theta is equal to, instead of W, we're going to put N2 because they are equal to each other. Sine theta over 2. Okay? الحين we know that N1, we can look at these two equations now together and simplify it even more. ليش؟ لأن الحين عندنا only two equations, all right? And we have a relationship between them. So we can just substitute N1 instead of N1 over here. So we're going to take this N1, we're going to take this value actually, and substitute it into this N1 over here. And this will give us N1 0.45, 0.45 times N2 cosine theta. All right, this is our left-hand side, is equal to N2, N2, you just make some space, N2 sine theta over 2. Then sine theta over 2. Where's theta? Over here. Okay? And that's it. And that's how you're going to solve the equation now. You can simplify this equation. First of all, you're going to divide both sides by N2. If you divide both sides by N2, you're going to see something that happens. Or you could just start solving normally and you will notice. يعني if we take this 2 up here, so we can multiply, so we can make it simpler. بيكون 2 times 0.45, which is 0.9. زين 0.9 N2 cosine theta is equal to N2 sine theta. And now we're going to divide both sides with this whole equation. So we're going to divide both sides by 0, not 0.9, we're going to divide by N2 cosine theta and N2 cosine theta. عشان we can get the cosine and the sines together and the thetas together, and we can finally solve for theta. You will also notice that your N2 and N2s will cancel, and N2 here will cancel with this N2, this N2 will cancel with this N2, the cosine theta will cancel on the left side, you will be left with sine over cosine. So 0.9 is equal to sine theta over cosine theta. Sine theta over cosine theta is what? It is tan theta. So sine theta over cosine theta is equal to tan theta. Okay? And now this is the relation between sine and cosine and tan. So tan of theta is equal to 0.9. And finally, we can find out that theta is going to be equal to the tan inverse of 0.9. That in the calculator. Tan inverse of 0.9. والجواب بيكون 41.99 degrees. And that is your final answer. See, the issue with this question is it takes a lot of time. I know it takes a lot of time. There's a lot of concepts that you're going to be using together. There is room for a lot of error. هذا هو المشكلة. There's room for a lot of mistakes. زين? So again, a quick recap on the whole question. في البداية كان عندنا smooth surface وكان عندنا rough surface. The smooth surface has no friction. Rough surface has friction. All right. فمعناته عندنا الكوفيشنت اوف فريكشن نقدر نطلع الفريكشن فاليو and then we start building equations and relationships. So first of all we know the friction equation اللي هو friction is equal to bu times n2. We apply that. Next thing we know is our sigma fx equation. We will apply that and get another equation. Sigma fy equation, we will apply that, get our third equation. Then the tedious work is going to be happening when we are trying to do our moment equation. Tamam? So when we do our moment equation, we're going to have to consider our distances, our perpendicular distances. So in this case, we defined our perpendicular distance to be y for n1. And since this is a uniform ladder, بيكون at half exactly the point of x, the perpendicular distance of it. So it's going to be x over 2. Then we use the trigonometry عشان we can figure out a relationship between y, x, and L so that we can cancel it all out. So we wanted one relation between y and L and x and L so that later on we could just plug them in here and cancel the L's out. So here we have L cosine theta and L sine theta. We found these as x based on the trigonometry. Now we also have our theta value, which we need to use, which we need to find initially. And now that we found our perpendicular distances, we can plug it into the moment equation. Remember, in the moment equation, you need to determine your positive direction. Usually I select clockwise, and I would recommend the same. بعدين you will go to each force and see the direction of the moment they're causing. So N1 is causing a moment. Yani you're going to draw a line going towards the point at which the moment is being calculated, and you will see the direction of it. In this case, it was clockwise. Same thing again, you're going to go to the weight, you're going to draw a line going towards the moment. In this case, it's counterclockwise. So we're going to put the signs depending on clockwise and counterclockwise direction. Then we are going to substitute each value. So in this case, this is going to be L cosine theta, and this is going to be L sine theta over 2. We're just substituting for x over 2 and for y. زين. Once we substitute our values, we notice that the L's cancel out and we can start solving, and we will get our fourth equation from the moment equation. بعدين we have to see and compare each equation with each other and see what is the most efficient way of cancelling. يعني I did it in this way. You guys, for example, could have kept the weight, could have kept the friction, but that substituted out the N1 and the N2. It would have worked exactly the same thing. You just need to make sure you are cancelling out as many factors as you can. And you see in the first 1 and 2 equations, we have 1, 2, and 3 variables, اللي هم N1, N2, and FR. But I combined them to eliminate to eliminate the FR variable, وبيبقى لنا only N1 and N2. Same thing at the bottom here. We had 1, 2, 3 variables. I combined them to eliminate one of the variables, so we'll be left with only N1 and N2. Now that we only are left with these two variables, we can simplify it, and then we can substitute and cancel out the last N2. And then we can simplify the equation by finding sine over cosine to find tan of the angle, and then it will be solved. صوتي راح. زين. شكله معقد، شكله وايد معقد، بس لأن أنا I'm going into detail a lot about everything عشان يكون واضح المعلومة. Most of the ladder problems are going to be very similar in terms of solving. The complicated part people usually have a difficulty with from last semester is the y and the x, and finding out the perpendicular distances and managing to find a relationship using trigonometry. This is so important. It's very simple, basic concepts. It's not even the concepts that are, يعني that people are struggling, that should be struggling with. ولكن يوم يكون في مليون ألف شيء على بالهم ينسون البيسكس مرات في الحل. لو اعتبرتها من أول واحد أحسن بتكون أسهل. 100% I agree. If I chose this to be 1 as unity, it would have simplified everything. But in this case, I am using L just in case they were giving us a value for L in another question. You guys will know how to solve if there was a value here instead of 1. But you are right, if you considered this to be a 1 meter ladder, زين, just for the simplification process, you can do that. Nothing wrong with that at all. Here you will not have any L's. You will just have x is equal to sine theta and y is equal to cosine theta, and then you will just go ahead. But if you notice, يعني the substitution, the L's instantly were cancelled out. There wasn't anything more to it. But you are so right. It does not, because this does not matter what the length of the ladder even is in cases like this. تمام. I want to solve one more. I really do want to solve one more عشان يكون عندنا another idea of how another question might look like. Let me look at question 2. Question 2 looks very similar. So in question 2, a uniform ladder rests on a rough ground and is propped against a rough vertical wall. The difference is you're going to have two rough surfaces. Coefficient of friction is 0.5 and 0.25 for the ground and the wall respectively. Find the inclination of the ladder when it is on the point of sliding. It is the exact same thing but even easier لأن هني معطيكم an extra يعني force to find, an extra equation from the beginning. You're going to apply the exact same concepts. The only difference is you're going to have one more extra friction force here. Let me try to find another question to solve. Okay, I want to solve the one with the man. I think that's the one. ترى I think semester اللي طاف إذا أنا مو غلطان, this is the question that came in the midterm, this first question that we're solving. They only gave them the coefficient of friction and told them to solve. And many people were not prepared for that. So I believe this was the very first, this was the exam question for last semester's midterm. فممكن ما يعيدونها, ممكن يعيدونها, you never know. But see, sometimes they can give you only one value and you can still find an answer. Let us solve question 4. This one. It's going to take a bit long, يعني a bit of time, but I think it's a very important concept I want to get out of the way right now. And we're going to do it step by step. Just give me a second, let me drink some water. All right. A ladder 10 meter long is propped against a rough wall at an angle of 30 degrees. Nice. They gave us the angle already of 30 degrees to the vertical. So we already know how this is going to look. So let's start drawing this. Let me make this a bit smaller. And then, so we have our vertical wall, we have our horizontal floor or ground. Then we have our ladder here, middle. We know that this is a 10-meter ladder. Okay, so we have the distance already given. And it is propped against a rough wall. So we know that there's going to be friction here. And we know that there's going to be friction down here as well. Okay. So again, we've found the 10 meter long against the wall and the angle of 30 degrees. معطينا الانgle with to the vertical. So this angle over here is going to be 30 degrees. تمام? So we're given the angle. Neglecting the mass of the ladder. So the ladder has no mass. And then mass of ladder is 0. M ladder is equal to 0. So we were not going to have weight due to the ladder. Find how far a man of weight W. And then this is where the weight is important. The mass, the weight of a man. So there's some man on top of this that has a specific weight. All right, so let's just assume that he's somewhere here. We don't know where he is. Then we need to find out. So we have a weight here of the man. Let's call this just W. All right. Can climb up the ladder before slipping takes place. يعني قبل ما ladder slips and falls. So in other words, they want it to be at equilibrium. يعني معناته we have to use sigma fx equals 0, sigma fy equals 0, sigma moment equals 0 again. All those things. The coefficient friction of the wall and the ground are 0.4 and 0.25 respectively. فأنا I will everything that is related to the wall, I will do in red. Everything that is related to the ground, I will do in blue. Okay. Now, so the wall, let's look at the wall. عندنا هني a normal force, obviously, in this direction. And we're going to have a friction force. What is the direction of friction force? Depends on the motion of the ladder. If the ladder is slipping, it is going to go downwards, صح? If the ladder is slipping, it will fall down. So the friction force is going to be up. Not down, up. So this is our friction force. Let's call it FR1. And let's call this normal force 1. N1. Okay? This is it, and we have mu here, which is equal to 0.4. Now, same exact thing, we will look at the bottom side. Just like before, if this is slipping, it is going to be slipping to the right. So the friction force is going to be to the left. So this is our friction force FR. And we're going to have a normal force going upwards, N2. So this is FR2 and N2. Okay? I use small f. This is what we have so far. This is all the things that we have so far. We also know that this is 30 degrees. So because we have 30 degrees and 10 meters, we can already find the perpendicular distances here and here. Yani, we know that this, if we are just going to draw the triangle again, this is the triangle. And this is where the ladder is, completing the triangle. عندنا هني 10. Okay? وعندنا الانجل هني معطينا اياه to be 30 degrees. زين؟ So we can find out the distances here using SOHCAHTOA. SOHCAHTOA. We know that this is the hypotenuse. We know this is the angle, the wall adjacent, and this is the opposite. All right? So we can start solving for the adjacent and the opposite. For the adjacent, for this one, we have given the h, so we're going to use h and a, which is cosine. So cosine, the adjacent, is equal to the adjacent over hypotenuse. بما معناه cosine 30 طبعا. زين. Cosine 30 degrees because we already have the angle. So cosine 30 degrees is equal to adjacent over hypotenuse. So therefore, a is going to be equal to the hypotenuse, which is 10 cosine 30. Tamam? So a is going to be equal to 10 cosine 30, which is equal to 8.66 meters. Okay, we found our A. Now let us find our B, or our O, sorry, our opposite side. طبعا the A, we usually call it our Y value, so we could say this is Y is equal to 8, which is equal to this. زين. Nope, let's take this all to the next side. خليها الصوب. And now let's solve for O. So this O is usually our X. So O, we have the hypotenuse, so we will use SO, all right? So A cos or sine 30 degrees is equal to opposite over hypotenuse. بما معناه the O is going to be equal to 10 sine 30 degrees. So X, which is equal to O, is going to be 10 sine 30 is 5 meters. So we found our X and Y values. We found that this distance over here is this distance from here till here is 8.66 meters, and this distance from here till here is equal to 5 meters. So this is the first step. We found out our dimensions because we know later on we're going to need them for the moments. We might as well get them out of the way since we are given the length and the angles. All right, using this method. Let me copy paste this down again one more time. The ladder has 0 mass. We already know that. Now we can start solving using our fx and everything. We can also start solving. Before even going here, let's solve up here the friction. We know that FR1 is equal to mu1, let's call this mu1, times n1, بما معناه FR1 is equal to 0.4 n1. Okay, and here we have mu2 2, which is equal to 0.25. So FR2 is equal to mu2 times N2. So FR2 is equal to 0.25 N2. This is our equation 1. This is our equation 2 that we might be using later on. Most probably will be using actually later on. Then, now, moving on to here, we have our first two equations. Now we can use our sigma fx and sigma fy's. Sigma fx equals 0. What is sigma fx? Sigma fx is equal to, and then n. Let's identify our positive directions. This is plus x. This is plus y. Okay. So n1 is positive, plus n1. And then fr2 is minus fr2. Minus fr2. fr2 is equal to 0. بما معناه n1 is going to be equal to fr2. This is our third equation. Okay. We could from now just substitute this back into one of these just to simplify, but I usually solve everything equation wise, and then when I find the final answer, I look at everything and try to solve it in that way to make it easier for me. Now we can do sigma fy. Sigma fy is equal to 0. Sigma fy is also equal to, let's look at the n2. It's positive n2, so plus n2. It's in the upwards direction. Then we have fr1 is also positive, so it's plus fr1. Then fr1 is also positive, so it's in the upwards direction, so it's plus fr1 minus what do we have? The weight. Minus the weight. And this is all going to be equal to 0. If we want to rearrange this, we're going to get weight is equal to n2 plus fr1. And this is our fourth equation. طبعا it's still not sufficient. Why? Because now we have an extra force, extra friction force, and then a 1, 2, 3, 4 unknowns. Then we have 5 with the weight, the fifth unknown, and we only have 4 equations. So we need to find the fifth equation to be able to solve. So now we need to find the fifth equation, which is using the moments, sigma m. At which point, it doesn't matter. You can choose at this point at the bottom or the top. I'm just going to choose 0.2 over here. Okay, I'm going to call it 0.2 to make it easier for me. So m at 2 is equal to 0. It's the same. It's nothing gets harder or easier. You can choose up or down. ولكن هني we are still missing the perpendicular distance for W. And we do not know which direction W is or where the location of W is exactly. ما عندنا إياه. إحنا we need to find that out. We need to figure out how far up can he go. زين? How far up can the man go? We are going to define this direction اللي هو from here to here. We will call this direction let's call this direction, because let's see the question what they're asking specifically. Okay, find how far a man can climb the ladder. So يعني نبغى احنا نعرف الديستنس على ladder. So let's call this من هني لين هني, this distance D. Okay, so this distance from here to here is distance D. This is what we are trying to find, our distance D. تمام? And we know that this angle is also equal to 30 degrees. So we know that we have a perpendicular distance. Where's our perpendicular distance now for the orange part? This is going to be our perpendicular distance, this orange part over here, which we do not exactly have the number for. However, we can use الحين الtriangular relationship for the orange triangle like this. زين. We know that this is the distance D. Okay, this is what we need to find. عندنا هني 30 degrees. Okay. We don't know what this distance is, but we already have D and we wanted to find it in terms of D. This is the hypotenuse, okay? And this is the opposite. So what are we going to use? We are going to use sine, because sine is opposite over hypotenuse. So sine 30 is equal to opposite over hypotenuse. So if we call this place, let's call this distance x. Then let's call this distance x in blue. This is x, okay? This is, I'll keep it in black. So this is the hypotenuse and this is the opposite. So x is going to be equal to, or sine 30 is going to be equal to x over d. صح ولا لا? Opposite over hypotenuse. X over d. تمام? Now that we have our x is our perpendicular distance, okay? So this distance over here, this distance, I'm just going to highlight it. This distance is x, okay? This is our distance x. So x is our perpendicular distance. We're just going to find it in terms of d because we need to find the value of d eventually anyways. So x is going to be equal to d times sine 30. Sine 30 is just 0.5. فمعناته x is equal to d over 2, or half of d over 2. تمام? So now we figured out a relation between x and d, Now we have this perpendicular distance. What other forces do we have? We have FR1. We have its perpendicular distance, which is 5 meters, because this is from point 2. And we have N1, which is 8.66 meters. So we have the perpendicular distance for each one. So for FR1, perpendicular distance is equal to 5 meters. And then this 5 meters is here. For N1, perpendicular distance is equal to 8.66 meters. This 8.66 meters is over here. What else do we have? We have our W. For W, the perpendicular distance is equal to x, which we still are going to figure out later, which is this x over here. Tamam? So we found all our perpendicular distances. Remember, N2 and FR2, their forces will cancel out because they don't have any perpendicular distance to this point. They're acting on the point itself. Now to finalize this, we can just write the moments equation. So sigma M2 is going to be equal to, let's start with FR1. FR1 times its perpendicular distance, which is 5 meters. All right, FR1 times 5. Then plus, we don't know plus or minus yet. We're going to check them out in a bit. We have N1 times its perpendicular distance, which is 8.66. With the last one, we have W, which is W times X. Okay, these are the distances we have. Now we are going to check for the signs. Obviously, these will all be equal to 0. Then, because sigma M2 is equal to 0. Let's go start with FR1. We are going to draw a line towards 2. So if we draw a line towards 2, it is going in that direction. So this is clockwise, so it's positive. Again, we are defining this as positive, the clockwise as positive. So the FR1 is going to be positive. Again, we're going to look at N1. It's going in the same direction, so N1 is also going in the positive direction. So this is plus. Lastly, W is going into the opposite direction. So we know that, let me actually not do it in orange, let me keep it in black. So W is going in that direction. This is in the counterclockwise direction, so it's negative. So we have minus W of X. And this is our final equation. If we simplify it a little bit more, it is going to be equal to FR1 times 5 FR1, which is just 5 FR1, plus 8.66 N1 is equal to W times 0.5 D, which is simply just X. X is equal to 0.5 D. All right. So this is just simply X. X is equal to 0.5 D. And this is our last equation, our fifth equation. Now we can just gather up all the equations together and start solving. So we have this equation. Okay. The first equation. We have our second equation. We have our third equation, N1 equal FR2 there. زين. بعدين عندنا our fourth equation, which is W involved. And lastly, we have the moment equation that we found here. This is equation number 5. زين. Don't get confused. This is not times 5. This is, I'm just numbering the equation 5. Okay. Let me just clarify that here as well. This is not times 5. This is just, we're calling this equation number 5. زين. Now, we can start simplifying step by step, piece by piece. أول شيء نقدر نحط ال N1 مثلا هني. زين. So we're going to look at equation 1 and equation 3. So 1 and 3. Okay. We're going to have FR1 is equal to 0.4 times FR2. Okay. This is the first simplification we can do. Next, we can look at this equation now, this same equation that we found, and use equation 2 to simplify N2 in it as well. Yani we're just going to plug in FR2 instead of the FR2 over here. So FR1 is equal to 0.4 times 0.25 N2 times 0.25 N2. Okay. So we have used equations 1 and 3, and now equation 2, we have also used it. الحين بيبقى لنا equations 4 and 5. Now in equation 4, we can plug in this equation as well again. So we're gonna take this equation now. This equation, let me put it in green, this equation. We're gonna plug in the FR1 into equation 4. زين. We're gonna plug it in into this FR1 over here. وبعدين we're gonna simplify it. So what we're gonna get is W is equal to N2 plus تعويضة كاملة, which is 0.4 times 0.25 N2. زين. The 0.25 N2 is the blue part, so 0.25 N2. زين. This is this blue part here. الحين, if you notice, we have an equation W, and we can just plug this in into the other equation, and we can resolve it again because we have a relationship between FR1 and FR2, and we can simplify everything together. وايد طار الوقت فما ابي اسوي substitution لما ينحل السؤال بس you get the idea and then we can find the distance d which is the distance of the man. The idea is eventually we're going to find a solution for d by itself after doing enough substitutions. All right. Sorry وايد طولت عليكم او at this point عليك انتي ده للحين موجودة سامحينا وايد